Well, folks, this is Sanjay Singh from Guruji Online, and today we are going to solve mock test paper dated 9th February 2020, which I had uploaded on my website, that is guruji-online.com. So the first question of the mock test paper is like this: what is the temperature corresponding to 330 Kelvin on a linear temperature scale X, where water boils at minus 50 degrees X and freezes at minus 180 degree X? So we are given scale X. This is X scale where water freezes at minus 180 degree and boils at minus 50 degree. Correct? So this is the freezing point, and this is the boiling point. Of scale X. We have been asked the corresponding temperature on this scale corresponding to 330 Kelvin. So what is the Kelvin scale? We already know this scale. This is Kelvin. Here the freezing point is 273.15 and boiling point is 373.15. Here we don't write degree, we denote Kelvin as it is. So this temperature is corresponding to this temperature is corresponding to this. Now this is 330 Kelvin, and corresponding to this we have to find out the temperature on X scale, and variation is linear. It is given here. That means in linear variation, you already know it is the straight line. In linear variation, what is the equation of the straight line? Suppose this is y, this is x, m is the slope, and this is c. Then what is the equation of the straight line? Correct? We can put these values here. When y is this 273.15, x is your minus 180 degree plus c, and when y is 373.15, This is minus 50 plus 3. So this is equation number 1. This is equation number 2. From these two equations, we can find out M and C. This M will come as 0.789 and C will come as 411. So, putting these values, we can find out X here, Y is equal to 330 is equal to M is 0.789 into X. We have to find out, and here 411. I hope this is correct. So, solving this, X you can find out as minus 106 degree X. So, this is the answer. So, in this question, we have been given one scale and correspondingly we have been asked to find out the temperature on this scale corresponding to 330 degree Kelvin. Kelvin scale we know like this. With these two equations, we can easily find out the solution. Now, we will go to the next question. Now, this is the question second. In this question, a brass ring is given whose diameter is 3.125 centimeter and a steel rod is given whose diameter is 3.130 centimeter. Now, you see its diameter is more than this diameter. So, this ring cannot fit onto this. And these two things are presently at 30 degree centigrade. We are also given this coefficient of expansion of brass is 19 into 10 raised to minus 6 per centigrade, and this coefficient expansion for steel, the 11 into 10 raised to minus 6 degrees centigrade. So, we have to find out at what temperature the ring will slide over rod. So, naturally, when we will heat up, when we will raise the temperature, this will expand and this will also expand. But since coefficient of expansion of brass is more than steel, it will expand more. And a stage will come when this will fit onto this rod. So let us see how to solve this problem. For brass ring, suppose if we raise the temperature by delta T, then how much will be the elongation diameter? This will be, this is original plus alpha B This is origin. This is the diameter basically into delta T. Basically, this will be the elongation and this is the original diameter. So, the sum will give you the diameter of the brass ring when you raise the temperature by delta T. Likewise, for steel, it is now. A situation will come when this will have the diameter equal to that, then it will fit onto the rod. That means in that situation, dB must be equal to ds. And so we can write it as dBO plus alpha B dBO, that is original, must be equal to D plus alpha D into delta T. Correct? So delta T we can find out. What is the temperature? From this equation, this will be equal to D minus dBO divided by alpha B dB minus alpha S ds. This you know 3.130, this you know 3.125, alpha B you know, alpha S you know, this already you know. So we can find out delta T by putting the values, and delta T will come as 200.4 degree centigrade. Now, this is the temperature you are going to raise from the original temperature. And original temperature was 30 degree centigrade. So, this is minus 230.4 centigrade, that is the answer. So this was the second question. Now we will go to the third question. So folks, this is the third question. It says, if one end of the rod is moving with velocity 90 nanometer per second, then at what rate the temperature of the rod is being changed by heating 3 centimeter portion of the rod. Condition is given, other end of the rod is clamped. And coefficient of expansion is also given. So in this problem, basically one rod is there. One portion, this end is basically clamped. You are hitting this portion, that is three centimeter. By hitting this, naturally this rod will expand, and due to this, since this and is clamped, this end will move in this direction, and it is given that it is moving with velocity v is equal to 90 nanometer per second. Correct? So now we have to find out at what rate this temperature is being raised or changed so that this end is moving with 90 nanometer per second. When the temperature is raised, you already know that elongation in the length is given by coefficient of expansion into L into delta T. Means if a rod of length L is heated or its temperature is raised by delta T, then it will elongate this much of length. Now, suppose we divide this delta L divided by delta T. This is basically temperature. This is delta T is time. Now it looks simple. What is delta L by delta T? That is this much of elongation in this unit of time, and this gives you the velocity, and this is what temperature, rate of temperature we have to find out. Delta T upon delta T will be nothing but alpha into L. V is nothing but 90 into 10 raised to minus 9 meter per second upon alpha we are given as 11 into 10 raised to minus 6 per centigrade into L is nothing but that is 3 centimeter. 3 centimeter, or we can write it as 3 into 10 raised to minus 2 meter. This we can find out. This will come as 0.273 centimeter upon second, or we can write this 0.273 Kelvin per second, because these two scales are the same. So this is the this is the answer of the third question. Now we will go to the fourth question. So this is the fourth question of the mock test paper. How long a 60 kilowatt water heater will take the temperature of water 200 liter from 30 degree to 40 degree centigrade? It's a very practical problem. Water is there. You have to raise the temperature of this water from 30 degree to 40 degree, and you have a water heater of 60 kilowatt power. That is P is equal to 60 kilowatt. Now, how much heat energy will be required? M into S into delta T. Delta T is what? That is 40 degree minus 30 degree. That is basically this is delta T. Water temperature is being raised from 40 degree to the initial final temperature minus initial temperature. What is S? Is your specific heat of water, specific capacity, heat capacity, specific heat capacity of the water, and this is the mass of the so this much heat energy will be required to raise the temperature of M mass of water from 40 degree to 30 degree. Now this is energy, and P is nothing but W upon P. This is, or you can write Q upon P, that is energy upon this work done upon time. Is we can write Q upon T also, because this is also energy, and this is nothing but M into S into 40 minus 30 upon T. That means T is equal to P M into S into 40 minus 30 upon P. Now we can put the values. This is 200 liter, or we can write it as kg. Specific heat of water is there 410 4190 joule upon kg per degree centigrade into this is 40 minus this is 10 degree upon this is P. P is 60 watt. So 60 into 1000. Watt is nothing but joule per second. So here this will be equal to, if you divide it by 60 more, then this answer will be 2.33. This answer will come in minutes. Otherwise, if we don't divide this by 60, then this answer will come in seconds. So, in 2.33 minutes, this water, the temperature of the water will be raised from 30 degree to 40 degree with 60 kilowatt of water heater. So it is a simple problem, but practical problem. So now we will go to the fifth problem. So this is the fifth problem. It is saying specific heat of a substance varies as 0.3 plus 0.15 T square. That means, in this case, specific heat is not constant, it is a variable. Find how much energy is required to raise the temperature of 4 gram of this substance from 10 degree to 15 degree. So like in previous problem, heat energy is nothing but EQ is equal to M as your delta, correct? This we can write it as S is given as 0.3 plus 0.15 T square. T is what? Temperature. This specific heat varies with the temperature. This delta T, we can write it as dT. And naturally this will become this much amount of heat will be heat energy will develop due to or will be required for changing the temperature from 10 degree to 15 degree. Naturally Q will be nothing but, if this is your 10 degree to 15 degree, 0.3 plus 0.15 T square, your dT, and this we can write it as M 0.3, take the integral 0.3 T plus 0.15 T cube upon 3. This will be 10 to 15. M is here 4 gram. Now, here gram is given. So, we don't have to convert in kg. We have to look at the units also, in what form they are given. Otherwise, you are going to commit the silly mistakes in the calculations. So, if we solve this, then this will come as 481 calorie. So this was the 5th question and this is the answer. So today we have solved from question number 1 to 5th, and tomorrow I will give you the solution of question number 6 to 10. So I hope you understood these problems and their solutions also. So please keep coming back to our YouTube channel on our website for having exposure of more and more questions like this pertaining to physics subject. Thanks for now. Goodbye.